In the previous couple of videos, we talked about fixed point iteration method, the condition for convergence of successive approximations to the root, and few examples to show that how can we apply fixed point iteration method to solve the equations. So now we are going to talk about the fixed point iteration method again, but then we are going to talk about the problem with the fixed point iteration method. And the problem with the fixed point iteration method is that let us see that the difference of nth approximation and alpha, this is less than or equal to k times alpha minus x n minus 1, means the difference between the root and n minus 1th approximation. So this represents the error between the root and nth approximation, and this represents the error between the root and n minus 1th approximation. What do we see over here? We see that for any two consecutive iterations, we find that this En is proportional to En minus 1. That is, this error in nth approximation is proportional to the error in n minus 1th approximation. In other words, it is linearly dependent, and hence the convergence is linear of the successive approximations. It means that this method is a slow method, and that is the drawback of this method. So in order to fasten this process, there is a method known as Atkins method, and this method accelerates the process of fixed point iteration. Now in this method, we need to first choose three successive approximations. So let us choose that xi minus 1, xi and xi plus 1 are three successive approximations. So we can write down alpha minus xi is equal to alpha minus xi minus 1 k times of this, and alpha minus xi plus 1 is equal to k times alpha minus xi. Now if I divide equation 1 by 2, what do I get? I get alpha minus xi by alpha minus xi plus 1 is equal to k times alpha minus xi minus 1 by k times alpha minus xi. And after cancellation of this, we can write down it as alpha is equal to, and solving, we get alpha equal to xi plus 1 minus xi plus 1 minus xi whole square by xi plus 1 minus 2xi plus xi minus 1, and this is Atkins formula. Now this formula can also be written in more compact and useful form. So for that, let us define that delta xi is equal to the difference of xi plus 1 and xi, and the second difference of xi minus 1, that is difference of xi minus 1, can be written as xi minus 1, or it can be written as delta xi minus delta xi minus 1, or xi plus 1 minus xi minus xi minus xi minus 1, that is xi plus 1 minus twice of xi plus xi minus 1. Hence this formula can be written as alpha is equal to xi plus 1 minus delta xi whole square by delta square xi minus 1. This is compact form of equation 3. Now, in order to understand it in a much better way, let us start with an example which we have already taken up in our previous video, that we found out the root of equation x cube plus 4x square minus 10 equal to 0, and this equation was written in x equal to g x form in various ways, and one of the form was x equal to 1 by 2 root over 10 minus x cube, and we saw that it satisfies the convergence condition. So for this one we did the calculation with the initial approximation 1.25, and first three successive approximations are these. Let us write down. So the first approximation is x1 is equal to 1.418351. Next is x2, and x2 is 1.33664, and x3 is equal to 1.3799477. So now we can construct a difference table. So the first difference is the difference between this and this, and this and this. So let us try to find out this difference. So this difference will be 1.336664 minus 1.41851, that is minus 0.081687, and the difference between these two values will be 1.37, these two values 1.3794777 minus 1.3366664, that is 0.042813. Now next we have to find difference of difference, that is difference of these two values. So 0.04 to 813 plus 0.081687. That is 0.1245. So using that formula, x4 will be x3 minus delta x2 whole square by delta square x1. This is what the Atkins formula is. Here I have taken I is equal to 2. So now x3 is this one, delta square delta x2 is this one, and delta square x1 is this one. Let us put these values. So my fourth approximation will be 1.379477 minus 0.042813 whole square by 0.1245, and if I solve it, it comes out to be 1.365. and as we can see here that the root correct to 3 decimal place is 1.365. So here I have got only in fourth step. On the other hand, for this case which we have considered here, for this case the root correct to 3 decimal places will be obtained after 7th approximation. So it means this is a faster method, and this makes the process of convergence